Spider Galaxy. If spiders gave you nightmares as a kid, consider yourself lucky the universe spun 10 million light-years away, where humans only rarely glimpse it. IC342, pinned to the constellation Camelopardalis, sits behind a thick swath of the Milky Way's gas and dust, masking almost all of its visible light from ground-based telescopes. Astronomers tracking this obscured spiral for decades record only faint hints until the mid-20th century, when observations in the infrared spectrum finally cut through the galactic haze. Because of this natural camouflage, most optical surveys miss IC342 entirely, underestimating its size and complexity for years. Infrared images reveal IC342's structure in striking detail, establishing it as one of the nearest grand design spiral galaxies to the Milky Way. Its most distinctive feature, a set of tangled, twisted spiral arms, earns it the nickname Spider Galaxy, since these arms project outward in a warped, web-like pattern rather than a uniform disk. Measurements suggest stretches of dust and star clusters span nearly 75,000 light-years edge to edge, comparable to the width of the Milky Way, but obscured enough that visible light telescopes detect only a dim blur. Therefore, astronomers must rely on wavelengths invisible to the human eye for both mapping and long-term study. The unique orientation and heavy dust absorption skew most early estimates of the galaxy's mass, rotation speed, and star formation rate. Only sustained radio and infrared studies clarify that IC342 ranks among the brighter spirals in the local group's extended family, supporting bursts of star production even in its masked state. Researchers therefore prioritize infrared missions, such as those launched by the Spitzer and Herschel space telescopes, when seeking new star-forming regions hidden from view. Many amateur astronomers nickname it the Hidden Galaxy for precisely this reason. Virgo A, also cataloged as M87, acts like the universe's bottomless buffet guest, always going back for another plate. This giant elliptical galaxy sits at the center of the Virgo cluster and measures over 120,000 light-years across. But it's the central supermassive black hole that dominates every statistic. Located 53 million light-years from Earth, this black hole tips the cosmic scales at an estimated 6.5 billion solar masses, making it one of the heaviest objects astronomers have ever tracked. In 2019, this very black hole earned worldwide attention when the Event Horizon Telescope captured the first ever direct image of a black hole's silhouette. Its orange ring confirmed key details of Einstein's general relativity. The activity around Virgo A's core reveals a feeding frenzy at an astronomical scale, as gas, dust, and even the occasional star vanish past the event horizon. The black hole does not quietly digest its meals. Instead, it drives energetic phenomena that shape the entire galaxy, including enormous plasma jets blasting outward for up to 5,000 light-years. These jets travel near light speed and are bright enough in radio wavelengths for Earth-based radio telescopes to detect them across intergalactic distances. Superheated matter in these jets offers astronomers clues about the extreme environment surrounding the black hole's accretion disk, and why Virgo A keeps radiating energy long after most elliptical galaxies have gone quiet. The cycle of consumption and expulsion continues as Virgo A vacuums up matter from its immediate surroundings, never reaching a point of balance or stasis. Researchers calculate that the energy output from its black hole regulates star formation across the galaxy, limiting new growth and reshaping local gas clouds. Because this supermassive black hole remains permanently hungry, it fuels not just plasma jets, but also enormous X-ray emissions detectable by satellite observatories. Astrophysicists sometimes joke that not even the cosmic all-you-can-eat line slows Virgo A down. Zombie Galaxy. Some galaxies don't just fade. They rise from the cosmic grave. Roughly 31 million light-years away, NGC 4625 earns its nickname, the Zombie Galaxy, after astronomers notice outer arms bursting with unexpected, vigorous star formation. For most spiral galaxies, the outer zones stay dim and quiet, often stripped of the dense gas clouds demanded by baby stars. But in 2004, NASA data confirms these outer regions in NGC 4625 are suddenly blazing with infant suns, registering star birth rates far higher than its quieter neighbors. Scientists say that in cosmic terms, this is like seeing a ghost leap out of a coffin and start running laps. Stellar population mapping shows NGC 4625's core remains dominated by decades-old stars. However, its periphery lights up in blue, pinning its timeline to a sudden, recent reawakening, rather than a gradual evolution. The dramatic change suggests a unique trigger, such as a gravitational encounter with a neighboring galaxy that stirs fresh hydrogen gas into the outer arms. With this raw material relit, new stars form more rapidly than at any prior phase in the galaxy's galaxy's recorded existence. Astronomers recognize this event not as slow aging, but as a cosmic reboot. NASA dubs this phenomenon galactic rebirth, highlighting how NGC 4625 transcends its earlier state through a demonstrable growth spurt in stellar mass. Analysis records that the rate and scale of new stars being forged far exceeds any low-level residual activity seen in long-lived galactic disks. The zombie label sticks because, against prediction, the once-faded outskirts animate with activity, creating a visual and scientific anomaly for spiral galaxies of its age. Throughout, NGC 4625 presents a startling case study, proving that even after fading, some galaxies can quite literally come back to life. Black Eye, 17 million light-years from Earth, lurking silently in the vastness of space, is a galaxy that seems to glare straight back at us. Officially cataloged as Messier 64, but ominously nicknamed the Black Eye Galaxy, or sometimes the Evil Eye. This celestial oddity was discovered in 1779 by British astronomer Edward Pigott. The eerie moniker isn't just a flight of poetic fancy. Its most iconic feature, a dark band of interstellar dust cutting sharply across its bright, glowing core, gives it the unmistakable look of a cosmic stare, like the universe's own version of a judgmental glare. That dust band isn't just an unsettling visual quirk, it's evidence of a violent upheaval. Scientists have determined that this black eye was likely caused by a major galactic collision, possibly with a smaller neighboring galaxy, billions of years earlier. The resulting chaos stirred up massive amounts of gas and dust across Messier 64, leading to ongoing star formation along the dark band we see today. Paradoxically, while its outer regions spin in one direction, its inner stars move the opposite way, a phenomenon so rare, astronomers initially thought their data was incorrect. It's like a galactic traffic jam where nobody agrees which side of the road to drive on. Apart from its unsettling appearance, Messier 64 might be one of the least welcoming places in the cosmos. Conditions inside the galaxy's dusty core make it unlikely to harbor planets, or life for that matter, in the same way Earth does. But that doesn't stop it from captivating astronomers who study its unique dynamics to better understand galactic evolution and collisions. The Black Eye Galaxy isn't just a cosmic oddity, it's a time capsule of destruction, regeneration, and the sheer unpredictability of the universe. This unsettling gaze into deep space is only the beginning. Other galaxies boast features no less haunting, like the empty voids of the Bodas supercluster, or the ghostly traces of dark matter shaping galactic filaments. Ghost of Mirach. Spotting a spooky patch of light next to a brilliant star sounds like a setup for an amateur's ghost story, yet for centuries, astronomers mistake NGC 404, nicknamed Mirach's ghost, for precisely that, because Mirach, a red giant and the brightest star in its corner of Andromeda, shines at second magnitude. Its glow overpowers the faint fuzz just a few arc minutes away, leading both historic and modern skywatchers to wonder whether this smudge is merely a trick of the optics or a true galactic neighbor. Records from the 19th century log repeated misidentifications, with some catalogs omitting the galaxy entirely. The confusion hinges on how classically diffuse and subdued NGC 404 appears, even in long-exposure images. Modern surveys confirm that Mirach's ghost is no illusion. NGC 404 is an actual galaxy, classified as a lenticular system lying approximately 10 million light-years from Earth. Its peculiar obscurity stems from a combination of physical faintness and unfortunate proximity, as the star's glare consistently drowns it out in nearly every amateur telescope field. Astronomers working with advanced digital sensors and diffraction suppression techniques only recently succeed in isolating its light from Mirach's nearby flare. This technical challenge means most astrophotographers overlook NGC 404 entirely. Its location works against discovery, regardless of intrinsic brightness. Despite its close distance on a galactic scale, NGC 404 is rarely photographed directly and rarely makes amateur lists of nearby galaxies. Its diffuse starlight requires careful subtraction of Mirach's dominating halo, so professional surveys, like the Sloan Digital Sky Survey, capture it primarily for calibration rather than detailed study. Because its composition appears oddly featureless, lacking striking spiral arms or a starburst core, it hides in plain sight, eluding attention even in wide-field galaxy surveys. The ghostly effect is not supernatural, just a function of optics, visibility, and celestial coincidence. Cannibal Galaxy. Andromeda, the nearest major galaxy to the Milky Way, takes the concept of a neighborly visit to a galactic extreme by actually eating smaller galaxies whenever it can. Measuring approximately 220,000 light-years in diameter, Andromeda dwarfs the Milky Way in sheer sprawl and has a documented history of galactic cannibalism that extends back billions of years. Astrophysicists track Andromeda's voracious appetite by tracing ancient star streams, unmistakable remnants of galaxies it has torn apart and consumed. Current models indicate Andromeda merges with one smaller satellite galaxy roughly every every billion years, and the evidence of these feasts still floats in wide arcs of disrupted stars. This aggressive growth strategy is not unique, but is especially well documented in Andromeda due to its proximity, roughly 2.5 million light-years away from Earth, and its bright, accessible streams of stellar debris. The galaxy's recorded mergers help explain its considerable size and dense core, both the result of repeated influxes of stars, gas, and dark matter from swallowed neighbors. Researchers use metallicity gradients and velocity data in these star streams to reconstruct the timeline of past collisions. Because these streams remain visible for billions of years, astronomers can map the cosmic diet of Andromeda, revealing not just the number of consumed galaxies, but how these violent snacks shape its evolution over time. Simulations show Andromeda's appetite is far from sated. A direct collision course with the Milky Way is set for around 4.5 billion years from now. This impending event will not involve stars smashing directly into one another, but gravitational forces will radically transform both galaxies' shapes and star distributions. Meanwhile, ongoing discoveries of new stellar streams in Andromeda confirm that the Cannibal process is continuous and central to the life cycle of large galaxies. It turns out, in cosmic neighborhoods, eating local carries a whole different meaning. Hoag's object. If galaxies handed out Best in Show ribbons for eccentricity, Hoag's object would sweep the competition by simply existing. Identified in 1950 by astronomer Art Hoag, this structure lies about 600 million light-years from Earth and immediately defies the norms of galactic formation. Its design features a strikingly perfect blue ring orbiting a compact yellow core, a combination so unexpected that astronomers cannot find any twins for this object anywhere in the observable universe. The ring's symmetry and color contrast suggest extreme stability, yet the mechanics behind such precision remain deeply unclear. Stellar surveys reveal that Hoag's object contains inner stars aged up to 8 billion years, older than our Sun by a wide margin, while the outer ring hosts much younger, blue stars forming more recently. Scientists propose various scenarios, from slow galactic collisions to gravitational lensing, to explain its unique appearance, but none fully match the data Hoag's object presents. Because of its one-of-a-kind structure and immense age gap between its core and rim, the puzzle only grows as closer observations improve. It's the galaxy equivalent of a cosmic bullseye, but with rules no one understands. Ultra, dark, giant. Imagine scanning the skies for galaxies and finding one hiding almost everything from view. Dragonfly 44 earns the nickname Ghost Milky Way for outdoing cosmic hide-and-seek. Astronomers uncover this ultra-dark galaxy in 2016 inside the Coma Cluster, positioned roughly 330 million light-years from Earth, and measure its mass to find something astonishing. Despite matching the Milky Way in total mass, Dragonfly 44 contains barely any stars. In fact, deep exposures reveal a few 100 million faint suns, 1,000 times fewer than the Milky Way's 100 billion, making the galaxy nearly invisible to conventional surveys. Because it barely emits light, initial studies miss its true scale, confusing it for a small patch of intergalactic debris. Detailed measurements quickly shift the picture. Using spectroscopy and the movement of bodiless clusters around Dragonfly 44, researchers calculate that 99.99% of its mass consists of dark matter, an invisible substance detected only through its gravitational influence. No other type of galaxy yet measured reaches this proportion, and Dragonfly 44's rotation offers the clearest evidence that star count and galaxy heft aren't always paired. The extreme ratio raises new questions about galaxy formation, as most massive galaxies develop hundreds of billions of visible stars, not just a sparse shimmer like Dragonfly 44. This finding highlights just how misleading visual brightness can be for mapping the universe's largest structures. Because Dragonfly 44 is as heavy as an average spiral, but fails to light up in any ordinary sense, it signals that hundreds or even thousands of similar ultra-dark galaxies might lurk undetected. Consequently, astronomers develop fresh survey methods, prioritizing the gentle wobble of star clusters and cloud movements over telescope images alone when hunting for massive unseen galaxies. Ongoing analysis in other galaxy clusters uncovers additional candidates with similar mass profiles, confirming that Dragonfly 44 is not a rare oddity, but a new class of ghostly giants. Thanks for watching. If you enjoy diving into the unexplained, hit that like, subscribe, and let me know in the comments which mystery I should uncover next. Until then, stay curious.